In this video, we will be starting with introduction to organic reaction mechanism. You know, in organic chemistry, reaction mechanism undergo many stages. There are many stages that go through in reaction mechanism, and within the stages, we have to apply some certain concepts. And these are the concepts we want to discuss today. These concepts will be used during our reaction when we'll be discussing about the reaction mechanism. The first concept is heterolytic fission. What do you understand by heterolytic fission, or what is generally known as heterolysis in organic chemistry? As you know, this is an uneven breaking of a covalent bond. An uneven breaking of a covalent bond. When there is in a covalent bond, a simple covalent bond has two electrons. They have two bonded electrons. And when there is heterolysis resulting in an uneven resulting in an uneven breakage, it means that the atoms involved in the covalent bond, one of the atom involved in the covalent bond will definitely leave with electrons more than the other one. So we say in heterolytic fission, the more electronegative atom takes both electrons in the covalent bond. In other words, we are saying that in heterolytic fission, the more electronegative element in the bond, the more electronegative element or the more electronegative atom in that covalent bond takes both electrons in the covalent bond. We will let me just give an example here. You have an example here, which is write an equation to show the heterolytic fission of carbon chlorine bond in chloromethane. Okay, this is a chloromethane molecule. This is chloromethane. We have this bond here. Here is a chloromethane molecule. This is a chloromethane molecule, which could be in this form. Okay, let me just put this. Okay, this is the molecule here. In this molecule, we have a chlorine atom and a carbon atom. There is a chlorine here. We have two bonds here. And there is the other bond from carbon. The other bond from carbon. So write an equation to show the heterolytic fission of the carbon-chlorine bond in chloromethane. Heterolytic fission. In this case, as we said, this is an uneven breaking of a covalent bond, where one of the atom goes with all the bonded electrons. All the electrons in the covalent bond, one of the atom goes with them. In that case, what happens? In a heterolytic fission, what happens? If there is a breakage, there will be a breakage here. And I said, the more electronegative atom takes both electrons in the covalent bond. Between carbon and the chlorine, there is a dipole here. This one is highly electronegative, and this one is a strong electronegative element, and this one and carbon is not a strong electronegative element. In that case, it acquires a partial positive charge. Meanwhile, this one has a partial negative charge. There is a dipole here. So in that case, when there is a breakage, when there is heterolysis in this carbon-chlorine bond, it results in an uneven. The result is this. The carbon atom then with the chlorine atom, this chlorine goes with what? With a double pair of electron. With a pair of electrons, sorry. And here, the one is left like that. That is what happens. In that case, we can say this has a positive charge and this has a negative charge.